This is a module 2 investigation 3, talking about constant rate of the change and linear function. So the constant rate of the change that we use in here, which is we use the m for the like a slope. This is a slope. Okay, for the linear function especially. Okay, so linear function formula is mx plus b, which is that's the give us the the line. So m is the slope, and which is the direction of the line, and b is a y-intercept. Okay, so let's start this problem. I will do number 5, number 6, and number 8 and 9. So in number 5, okay, let me see, where's number 5? Okay, number 5 here. Okay, so constant rate of the change we visited. So when you have 2 points of the x sub 1, y sub 1, x sub 2, y sub 2, in order to find the slope is, you need to subtract the 2 y's on the top and subtract the 2 x's on the bottom, which is we call the numerator is a change in y and denominator is a change in x, and then that makes the slopes. Okay, so that's the same thing. So the change in y is always equal to slope times the change in x. Alright, so delta x equal to m times delta x, delta y is equal to m times delta x, or delta y is the same as y sub 2 minus y sub 1, which is equal to m times delta x, same as x sub 2 minus x sub 1. So each of the following represent the situation with a constant rate of the change, using the definition above to explain what this statement means. So A, delta y is equal to 6 times delta x, which means you can start it as the value of the x and y change together. The change in y, which delta means a change, okay? So change in y is always, and then you need to complete the sentence, okay? Always 6 times as large as the change in x. Okay, B, delta y equal to negative 2 times delta x. So changing, so as the value of the x and y change together, so changing y is always, this time is a negative 2 times, as large as the change in x. Okay, so we can talk about this stuff at 2.1 using the under 2.2, right? The COVID-19 death. All right, let's talk about number 6. The given x and y are changing together at the constant rate of the change, that is delta x equal to negative 2 times delta y. Now, when x equal to 1, y equal to 7, construct the graph of y in terms of x. So I'm going to make a graph here, okay? So in the graph, okay, let me plot the point when x equal to 1 to y is a 7. 1, 2, 3, 4, 5, 6, 7, right here. And then since the slope is, since the slope is negative 2, which is same as negative 2 over 1, so slope is always give us a direction, but slope is always change in y over change in x. So there's a change of negative 2 on y, and there's a change of the x as a 1. So you go from here, right? You go 1, 2 down, and 1 right, okay? So which means you end up with here. And then do it again. You got 1, 2 down, and 1 right. So you end up in here. And then you go 1, 2 down, and 1 right. Now you end up here. And then you go 1, 2 down, and 1 right. And then you go right here. And then you can go, let's go one more. You go 1, 2 down here, and then you are here. So which is right here. And then if you connect all this point together, it's gonna give us a very nice linear line. Okay, so that's a line. Alrighty, so that's A. And then B, as x increases from the 1 to 5.5, how does the y change? Illustrate the change in your graph, okay? So let's do it. So let me use the red. So from the 1 to change the 5, right? So 2, 3, 4, 5. So 5 is right here, okay? So from here to here. Oh, 5.5, sorry about that. 5.5 is right here. So we change from the 1 to 5.5 is about here, right? So x changed this much, okay? And then how does the y change? Okay, so y change will be from here, you need to go down all the way to down here, all the way down here. Okay? So when x change it, the y change as a graph. So does x so how much it change as a y value here? So we're looking for the change of y from negative 2 times of how much the change in x? The change in x, this one will be from the 5.5 subtract 2, which is 4.5. So it's going to be 4.5 change in x. Together it's going to be negative 9. So it changed that. So this is a 4.5 change, but it's going to, y is a negative 9 change. So does the x take all the value between the 1 and 1.5? Yes, it is. So as you look at the graph, it is a solid, isn't it? So it takes all the value of the x's. If so, how this illustrated on your graph? So which means since x varies continuously from the 1.1 to 5.5, it takes all the value between these two numbers, which is 1 to 5.5. The solid vector represents the change in x from the 1 to 5 as a horizontal, and then can be used to illustrate the variable takes on the every value that lies on the vectors of the delta x, okay? So because you can see that all the solid, right, which is takes all the x from the 1 to 5.5, okay? So yes, so answer is a yes. All right, okay, and then let's go to the problem 8, okay? So the problem 8 talking about the also slope intercept form. So at the when we have y equal to mx plus b, it's actually the slope intercept form. Okay, but we also have a point slope form, which is the formula is this one. So slope intercept form means you're using the y-intercept as a b, and then use a slope to create the equation of the line. But if your point is not a y-intercept, which is you can use that the y minus y1 equal to m times x minus x1, okay? So what does x and y represent in the point slope form of the linear function? So x and y in the point slope form of the linear function represent the value of the two varying quantities related by the linear relationship between the order pair x and y. They all satisfy the linear relationship. So this x and y is come as an order pair. And then also satisfies the linear relationship. Okay, so it's going to be the varying two quantities. So it keeps changing by the equation. So describe the situation in which the point slope form of the linear function is useful. So yes, the point slope form of the linear function is also useful when you provide a constant rate of the change as well as the order pair in the relationship. So as long as you have a slope, which is m, and then as a order pair, which is x and y, and then it's going to be really useful as a relationship, okay? All right, let's look at the number 9. Given that the x and y have the same scale of the both of this graph, answer the following questions. So graph of the linear function a and graph of the linear function b. So since the graph of the a is increasing, which means the change of the constant rate of the change is going to be the positive. So slope is a positive, right? Slope is a positive. But for the function b is, since the graph is decreasing, so this time is the slope will be the negative. So what is approximate constant rate of change of y with respect to the x in the linear function? So we are looking for the constant rate of the change. So constant rate of the change, well, they say they're going to use the same scale for the both x's. So this is a length is about, let's say, if you kind of put it in, can I say about 3, isn't it? So there's a 1 as a xy change, and that means that there's a 3 as a the change in x. Okay, so in order to put that, always the delta, so the delta m is a delta y over delta x, which is a 1 over 3. So it appears that the change in y is about the 1/3 times as large as the change in x. And then the b, which is the slope, is delta y over delta x. Okay, so this time I want to see that this is about the half of the length of the delta y, which means I want to say it's going to be, but it's a negative, so negative 2 over 1, which is negative 2. So which is it appears that the change in y is about the negative 2 times as large as the change in x. Okay, so in b, what a formula expression expresses delta y in terms of delta x. So delta y over delta x is, oh no, I mean the in terms of delta x, right? So which is, we have to put that as the change in y is going to be 1/3 times as large as the delta x. For the b is delta y, which is change in y, is equal to negative 2 times as large as the change in x. Okay, and then c, write the formula expression y in terms of x given the y-intercept on the function that has a 3, and the y-intercept for the function b is a negative 3. Okay, so if you put that as y equal to mx plus b, so for the function a is slope is 1/3 x, y-intercept is a 3. For the function b is y equal to mx, which is a negative 2x, and minus 3. That's it. So y-intercept here, so it's about 3. And this is about negative 3. Okay, all right, so that's how can they explain. All right, this is about 2.3. Okay, thank you.